So now these are the keywords in C Sharp. Like I said, they are divided into 10 categories. We have the value type, the reference type, the modifier keyword, the statement keyword, the method parameter, the operator keyword, the conversion keyword, access keyword, literal keyword, and the namespace. So under the value type, int, char, byte, double, enum, float, long, struct, unit. Under the reference type, class, delegate, interface, object, string, void. Modifier keyword, public, private, internal, protected, abstract, partial, sealed, static, unsafe, virtual, volatile, new, override, event, cons. Let all these words not bother you. You are going to get used to them once you start writing code. So under the statement keyword, we have the if, else, switch, do, for each, in, while, try, catch, finally. Under the method parameter, we have params, in, ref, out. Operator keywords, we have as, is, new, size of, type of, true, false. Conversion keyword, we have explicit, implicit, operator. For access keyword, we have the base, this. For the literal keyword, we have the null, default. For the namespace, we have namespace using extern. Now, the contextual keyword. These are used to give a specific meaning in the program. Whenever a new keyword comes in C#, it is added to the contextual keyword, not in the keyword category. This helps to avoid the crashing of programs which are written in earlier versions. I hope you get this. Then for the operators, we have arithmetic operators, relational operators, logical operator, bitwise operator, assignment operator, conditional operators. And these are, for arithmetic operators, we have plus, minus, division, multiplication, modulo, increment, decrement. And you can see the signs that are used for them there. So the relational operators, you have the equal to, the less than, greater than, equal to or greater than, equal to or less than, and not equal to. For the logical operator, you have the and, the or, and the not. You can see the signs that are used. Then for the bitwise operator, you have the and, you have the or, you have the zo, you have the left shift, and you have the right shift. We are going to see how all these are used in this course. Then for the assignment operator, you can see we have equal to assign a value to a variable. You see that we can use the equal to sign to assign a value to a variable, but in order to use equal to as a relational operator, we have to use the sign twice. Note that difference. Then to add an assignment, you can see the sign plus equal to. To subtract assignments, minus equal to. To multiply assignments, asterisk equal to. To divide assignments, slash equal to. To modulo the assignments, modulo equal to. To bitwise exclusive or assignments, raised to power equal to. To bitwise inclusive or assignment, exclamation equal to. Then the conditional operators, this is how it's used. Condition, question mark, first expression, colon, second expression. So that's how it's done. Then now for control structure, like we saw in the curriculum, these are just statements, control statements that are used. So we have the conditional statements. They are the if else, if, nested if, switch, nested switch. Then we have the loops, while loop, for loop, do while loop, nested loop. The jump statement, we have the break, continue, go to, return, throw. We are going to go into all of this. Then the class and object. Class and object. Classes and objects are fundamental elements of C# programming and programming in general. A class is a user-defined blueprint or prototype from which objects are created. An object is basically an instance of a class. By instance, I mean it's an example of a class. Like being an instance of something an instance. I hope you understand that term there. It's an instance of a class, like an example of a class. So to declare a class, you need modifiers, you need a keyword, you need a class identifier, you need a base class or a superclass, which is optional. You need interfaces, which are also optional. Then you have the body of the class, and this body is surrounded by curly braces. So you also have constructors. Constructors are used to initialize objects. Once you create an object, which is an instance of a class, you can use a constructor to initialize it. By initializing, it means that you are giving that object now an initial value. You are initializing it. So let's see an example of a class. Look what we have here. Declaring a public class. Notice this backslashes here. Double backslashes are used to write comments in C# programming. Declaring public class, we have public class geeks. This public now, it stands for the modifier. It's an access modifier. It says that this class is public. Then public class geeks. This geeks now is the name of the class. Then now, this is the field variable public int a, comma b. This just declares two public integers without assigning them to any value. It says that they are public, which is the access modifier, integer, which is the data type. Then the first integer here is a and the second integer is b, but no value have been assigned to this. Then next we have member function or method, public void display. This public void display just states a method which is called display, and the void here means that this method is not going to have a return value, and the public here is also the access modifier. Then this is what the method does. It consoles.writeLine this string, which is class and objects in C#. So when you are writing things to the console in C#, you use console.writeLine. Then now an object. As I earlier said, an object is simply an instance of a class. But let's see what we have here. Object, it's a basic unit of object-oriented programming and represents the real-life entities. A typical C# program creates many objects which, as you know, interact by invoking methods. An object consists of a state, which is attributes of the object, behavior, identity, which is the unique name of the object. So now declaring objects, which is also called instantiating a class. Like I just said, an object is an instance of a class. So this is how it's done. You use the class name identifier is equals to new class name with parentheses. So now let's see what a static class is. In C#, a static class is a class that cannot be instantiated. What this simply means is that it's a class that has only one instance. It means that you cannot create objects of that class. It only exists once, and that's all. Like the name implied, static. So let's see, the main purpose of using static classes in C# is to provide blueprints of its inherited classes. Okay, once we move further in this course, we would understand what some of these terms are. For instance, inherited classes here may sound strange to some, but we would get there. So static classes are created using the static keyword in C# and .NET. A static class can contain static members only. You can't create an object for the static class. I just said this. Static class is a sealed class and cannot be inherited. So there are advantages of the static class, and you should note that static class constructor is parameterless. This simply means that the constructor doesn't take any parameters in order to initialize an object, because an object cannot be created for the static class. So we have the partial class. A partial class is a special feature of C#. It provides a special ability to implement the functionality of a single class into multiple files, and all these files are combined into a single class file when the application is compiled. You can see this is different from the static class. You can implement the functionality of a class in multiple files. So a partial class is created by using a partial keyword. This keyword is also helpful to split the functionality of methods, interfaces, or structure into multiple files. So there are important points for the partial class, and these are here. We would go more into this as we move on. So structure. A structure in C# is simply a composite data type consisting of a number of elements of other types. A C# structure is a value type, and the instances of objects of a structure are created in stack. We are going to go deeper into this. There are some strange words here, I know, but we are going to go into them. The structure in C# can contain fields, methods, constants, constructors, properties, indexers, operators, and even other structure types. So this is how to declare a structure and create objects. So you should have the modifier, which could be public, private, internal, protected, and so on. Struct, which is the keyword, then then after the keyword you have the struct name. So for instance, you could have private struct Somtochukwu, which is my name, and so on. Then the struct members now would be inside the curly braces. For instance, the body of the struct. So for example, you can have struct my struct, and you have the struct members inside the curly braces, which in this case are public int x and public int y. In this example here, no modifier was used. There's no public, no private, nothing was used. So now the object of a struct. You can see how the object of the struct is created. From the previous slide, you saw how to create objects. You have my struct, which is the name of the struct. Then now you have ms, this is the name of the object. Then you have the keyword new, and you have my struct with parentheses. I discussed this. So let's note, structs objects can be created without using a new, unlike C#. But fields in struct remain unassigned, and the object can't be used until all of the fields are initialized. Fields are basically variables. For instance, this int x, int y, they are fields. So what are they saying here? They are saying that fields in the struct remain unassigned, and the object can't be used until all of the fields are initialized. You can see that these int x and int y are not assigned to any number, like they are just declared here. They are not. You did not say public int x is equal to 1, public int y is equal to 2. You just say public int x and wrote full stop. Your semicolon here just means like full stop in C#. Your semicolon. You didn't assign them to any value, you just declared them. So they are saying that the object can't be used until all the fields are initialized. These fields that you just declared that are unassigned, you have to initialize them first before the object can be used. And how do we initialize? Using constructor. So let's see how that is done. A C# struct can declare a constructor, but they must take parameters. A default constructor, which is a constructor without any parameters, are always provided to initialize the struct fields to their default value. The parameterized constructor inside a struct can also be overloaded. This word overload is also a word that we would get used to as we move on, so just stay tuned. Now let's discuss methods. When we just discussed objects, we saw that methods are what the objects do. Like, what does this object do? It does this method. It has this method. So let's see what they are. Methods are generally the block of codes or statements in a program that gives the user the ability to reuse the same code, which ultimately saves the excessive use of memory, acts as a time saver, and more importantly, it provides a better readability of code. So basically, a method is a collection of statements that perform some specific task and return the results to the caller. It returns the results. But remember, when a method does not return any value, the return type is void from moments ago. A method can also perform some specific task without returning anything. What I just said. Example, method name getCircleArea. The return type of this is double. So now this is how to execute this method. Static double getCircleArea double reduce. Let me explain this first line. Static means that it can't be instantiated. It has only one instance, right? Double is the data type that this method is meant to return. GetCircleArea is the name of the method. Double reduce is the method parameter. Double here is just the data type of the radius. The radius could be 4.6, 5.4, and so on. Double radius. So you have to include the method parameter here in order to use this parameter inside the method. So what's in the method? We have constant float pi is equals to 3.14 f. Constant here is trying to let us know that this pi is a constant. Float is the data type of pi and is equal to 3.14. Whenever you are assigning float values, you have to include f at the end to show that it's a float. Then now, to write the formula for the area, double is the data type, area is the name of the variable, and is equal to pi times radius times radius. From general maths, we know that the area of a circle is equal to pi r squared. So this is an easy way to write it in code. So at the end, you have to include return area so that it will return the area from this method, and you can see that the data type of the area is double, so that's why you have to put static double when starting the method. So this is how to declare a method, like I just explained. Access modifier, your public, private, internal. It was not used here. It's actually optional. Your return type, in this case, is double. Method name, for in this case, getCircleArea. Then parameter list. In this case, the only parameter we need here is the double radius. The pi was included inside. So this is how to declare a method. So we have the method signature. The method signature is defined mainly by two parameters: number of parameters, type of the parameters, and order of the parameters. One of them is the method name and the second is the parameter list. These are what I just explained. But there are certain predefined rules for naming method which a user must follow. The method name must be some kind of noun or verb. The naming should be in such a way that it must describe the purpose. The first letter of the method can either be a small letter or a capital letter. However, it's recommended to use the capital one. Then method calling, you have your identifier, parameter list. The identifier is the name of the method, parameter list is here. Then example method sum. Okay, example method sum with parameter x and y. So this is what I just explained earlier. Then method parameters. I've explained this, but let's see what we have here. There might be certain situations the user wants to execute a method, but sometimes that method requires some value input in order to execute and complete task. These input values are known as parameters in computer language terms. So now these parameters can either be int, long, float, double, char, however it depends upon the user requirements. The methods in C# can be classified into different categories based on the return type as well as input parameters. For example, you have your static void, print sentence. This type doesn't even have a method parameter, and it's a void. It doesn't have a return value. It just prints a line, no parameters, and return type void. So now this one has a return value, which is int, static int sum, int equals a comma b equals to 0, add, and add is equals to a plus b, return add. Then method overloading. Recall the word overloading came up some time ago. Now let's see what it is. It is the common way of implementing polymorphism. Polymorphism is one of the core concepts of object-oriented programming. We are going to look at it later on in this course. It is the ability to redefine a function in more than one form. A user can implement function overloading by defining two or more functions in a class sharing the same name. C# can distinguish the methods with different method signatures, i.e., that is, the methods can have the same name but with different parameter lists. That is, the number of parameters, order of parameters, and data types of the parameters within the same class. All this is trying to say is that the same method could do different things, and that concept is called polymorphism. And in method overloading, how to achieve polymorphism is to use different parameters inside those methods, and they will be able to achieve different things. So these are different ways of doing overloading methods: the number of parameters in two methods, the data types of the parameters of the methods, and the order of the parameters of two methods. Alright, so we have come to the end of this lecture, and this is the end of the week 1 lecture. So don't forget to like, comment, and subscribe. Thanks for watching.